When history tells of great civilizations, it often names their kings, their wars, their inventions, but rarely the humble plants that kept them alive. One such plant has quietly sustained communities for more than 4 millennia, thriving where other crops withered and leaving the soil richer than before. Its roots stretch deep into both the earth and human history, playing a silent role in the survival of empires, trading routes and small farming villages alike. This crop is not just a relic of the past. It still holds secrets that could help modern gardeners restore exhausted soil without chemicals or costly fertilizers. The plant in question is the lablab bean, also called hyacinth bean in some regions. In ancient Africa and Asia, this climbing legume became a cornerstone for farmers who worked thin, nutrient-poor land. Its legacy is a testament to how nature, when wisely managed, can repair itself and create abundance where scarcity once reigned. The lablab bean story begins in East Africa, where it was first domesticated thousands of years ago. Traders carried its seeds along the Indian Ocean trade network, and soon it was flourishing in India, Southeast Asia, and even parts of the Mediterranean. Ancient farmers didn't know about nitrogen fixation in the modern scientific sense, but they observed something remarkable. After growing lablab, their next crops grew taller, greener, and yielded better, even in fields that had been nearly barren before. The secret lay underground. Lablab's roots form nodules that house nitrogen-fixing bacteria. These microorganisms capture nitrogen from the air and convert it into a form plants can use, a process that enriches the soil naturally. Where many crops drain the earth's reserves, lablab actually replenishes them, ensuring that year after year the land improved rather than declined. One of the reasons lablab endured as a staple crop for so long is its versatility. The immature pods are edible as vegetables, the mature beans can be dried and stored for long-term food security, and the leaves can be eaten fresh or cooked. In times of scarcity, its vines were even used as animal fodder, keeping livestock alive through lean seasons. But its role in soil building was equally important. Farmers would often plant lablab alongside staple grains like millet or sorghum. The bean would climb the stalks, shade the soil, and drop nutrient-rich leaves that decomposed into humus. After harvest, the remaining vines and roots were turned under as green manure, returning organic matter and minerals to the earth. This cycle meant that instead of depleting their fields, these farmers were actively improving them, season after season, generation after generation. Lablab is a survivor. It tolerates drought once established, thrives in sandy or clay soils, and can handle acidic conditions that would stunt other crops. In ancient farming systems, this meant it could grow in marginal lands where more delicate crops failed. By covering the ground, it also helped prevent erosion, an invisible but critical service in keeping thin soils from washing or blowing away. In the Indian subcontinent, farmers took advantage of its resilience by sowing it as a cover crop after monsoon rice harvests, letting it protect and enrich the soil until the next planting season. In East Africa, it was used as part of shifting cultivation systems, helping land recover between cycles of grain production. While lablab's role in history is fascinating, its potential today is just as exciting. Modern gardeners often face soil that's been compacted, depleted, or chemically imbalanced. Synthetic fertilizers can force plants to grow in the short term, but they do little to restore long-term soil health. Lablab offers a low-cost, sustainable alternative that works with natural processes. Planting lablab as a seasonal cover crop can boost soil fertility without tilling or expensive amendments. In warm climates, it can be sown in spring and allowed to grow through summer, providing a living mulch that shades the soil, suppresses weeds and feeds beneficial organisms. Its deep roots help break up compacted ground, creating channels that improve water infiltration. Even in cooler regions, Lablab can actually be grown during the warmer months, then cut down before frost and left as mulch over the winter. The decaying biomass, feeds earthworms and soil microbes, really setting the stage for healthier spring planting. One of the most effective ways to use lablab today is as part of a polyculture. Intercropping it with tall crops like corn or sunflowers, well, that actually mimics ancient practices, allowing the bean to climb while the main crop benefits from the enriched soil. In home gardens, trellises or fences can support the vines, which in turn provide shade for more delicate plants underneath. Organic gardeners also value lablab for its role in integrated pest management. The dense foliage, you see, provides habitat for predatory insects that keep pest populations in check. Meanwhile, the flowers attract pollinators, boosting yields for nearby fruiting plants. For gardeners looking to avoid chemical fertilizers altogether, lablab can be grown in rotation, one year as a food crop, the next purely as green manure. The biomass it produces when cut and incorporated into the soil is rich in both nitrogen and carbon, making it a balanced feedstock for microbial life. In a world where climate instability is affecting food production, crops like lablab that can withstand heat, poor soils and inconsistent rainfall are gaining renewed attention. They offer a safety net for farmers and gardeners alike, reducing dependence on fragile supply chains for fertilizers and soil amendments. By learning from historical practices, we can build systems that are both productive and resilient. Lablab's ability to improve soil over time means it's not just a stopgap, it's an investment in the future of the land. For smallholders, homesteaders and community gardens, this ancient bean offers a way to grow food while actively repairing the ground beneath it. When you plant lablab, you're participating in a tradition that stretches back thousands of years. You're tapping into a form of agriculture that doesn't fight nature but collaborates with it, using biology instead of industry to create abundance. The same plant that sustained farmers in ancient Africa and Asia can still feed both people and soil today. If the past teaches anything, it's that true sustainability isn't about squeezing every last drop from the land. It's about giving back, ensuring the next harvest is better than the last. The lablab bean embodies that principle, making it as valuable now as it was in the dawn of civilization. Across 4,000 years from dusty African plains to the terraces of India, this plant's quiet work has enriched soils and sustained communities. Its story is more than agricultural. It's a reminder that the solutions to our most pressing problems often lie in the knowledge our ancestors left behind. For the modern gardener, the choice is simple. Bring this legacy into your own patch of earth and watch as it transforms not just your harvest, but the health of your soil for seasons to come. If you found this journey into agricultural history and practical gardening useful, subscribe to In the Beginning for more deep dives into the forgotten wisdom that still shapes our world. Share this video so others can rediscover the ancient tools that make our modern lives richer.